Hi Sharks! Today we've brought to you an automatic book page turner. You may be asking yourself, why is this necessary? Well, there are a multitude of reasons. 1. Studies have shown that 79% of kids from the ages 2 to 5 get read to at least 3 times a week by a parent. And most of the times, that parent is reading upside down. Wouldn't it be nice if they had an automatic book page turner so they could sit back, read normally, and their kid could be up close and personal with the book?
So here we can see how this works. When I press the forward button on this IR remote, the motor turns on, pushes the servo forward, which then turns the page and moves it back. You can see then you can turn the page remotely. I can be way over here, and if I want the next page turned, it's ready to go.
I'm not fully convinced that this project is very marketable. Can you tell me a little bit more about why people need it?
Have you ever been in your bed late at night? If you want to read, sometimes you just want to be cozied up in those blankets. That is yet another reason why our product is useful. You can read to kids, you can read to yourself, and overall, it is a general tool that will help with convenience and providing a better experience for the users, which will enable them to read more.
So here we can see it a bit closer. We have 3D printed parts. This is a circular bit that creates an overall piston. So when this motor turns, this part goes forward. I'll demonstrate that now. You can see it pushes the servo forward and turns the page. And the servo always resets to be ready for the next page turn. This here is a rubber tip, which is very helpful for grabbing onto pages. And we want this to move forward and backward so that the servo isn't interfering with the pages when it moves to turn the page.
After seeing the mechanical side of how things work, here's all the code and how the internals work. First of all, we include all of the libraries and set up every single one of the things. In void setup, we'll begin the servo, the stepper, and the serial monitor. And here's the full wiring diagram. So you can see the components that we have. We have the IR sensor to be able to take the IR signal from the remote, the converter, which converts the stepper motor, seen over here, to be able to be plugged into the board, and also the servo motor, which houses the pencil and the rest of what we have. A couple more things that can be seen with the wiring diagram is that it's only connected to get power to the rest of the system from the 5V and also to ground. This means that it could be easily adaptable to be made into a simplified version. Also, instead of connecting the whole system to a laptop, it could also be made easier by connecting it to a battery, which is definitely possible and was attempted by the team and did work. Continuing on with the next part of the code, we start off the IR receiver taking in inputs, and then this is a switch. A switch basically goes in and takes different cases, and based on those different cases, it'll do different things. In this case, it will do what's told and go in and move the stepper motor, move the servo motor in the configuration shown, which can also be shown here in our diagram, which first starts, begins the serial monitor, the IR receiver, and sets the servo. And then, if the button is being fast forward, we delay, rotate the stepper, and do all this, which will essentially make the page turn forward. On the other hand, going backwards is a bit harder. Starting off in this case, this isn't something that we really tested, but the code does have a way to do it. It's a different case which will go in and do the steps in a completely different order. Whereas turning the page forward requires the whole thing to move forwards and then turns the servo to the left to flip that page backwards and then back to starting position with the servo. This one will instead first move the servo to the left to prevent it from flipping the page, forward, move the servo to the right, which will then flip the page in the correct direction, and then move it backwards again. This is also showcased here in the flowchart, and instead of making a switch, what I did was 2 if statements, which showcases it the same way. Afterwards, this text is exactly what I just explained, which is different than the other one, hence the whole movement of the flowchart. Now that we've showcased how the entire project works, we can leave our decision with the Sharks.
So Sharks, who's ready to make a